Hello student, in this video we will discuss about heating effect of electric current. So heating effect of electric current means what? Whenever the electric current pass through to any conductor or any device, so that device and conductor get heat up. So why that conductor and the wire get heated up, we will discuss here. For example, student, this is the cell and the battery, and you know the cell and battery contain the chemical energy. Okay, and that chemical energy in the form of chemical compound. So in that cell, the chemical reaction takes place. Yes, and because of that, the charge, electron and a charge start to move. Okay, and you know when the charge start to move, so potential difference would get generated, and because of the potential difference there will be flow of electric current. Yes, now to maintain the electric current, yes, the chemical energy which is present in this cell keep on converting into the electrical energy or into the electric current. Yes, whatever the energy present in the cell, that keep on converting into the electrical energy. Yes, so what will be there after the formation of the electrical energy or electric current? So some energy is used to run the any device, and rest of the energy heat up that device. Yes, you can see whenever we play the game and use our mobile phone, cell phone, so after the certain period of the time, that device and mobile phone get heat up. Yes, so why? Because the rest of energy heat up that device. So heat this device is getting heat up. Yes, so this process is known as electric current, heating effect of electric current. Yes, and this process is also known as Joule's law of heating effect. So student, here one of the mathematical derivation we will try to make you understand here. So look at here, if we consider the electric current I is flowing in the resistor, and potential difference V is generated on the resistor, so what will be there? So V, you know, as you know the formula of the potential difference is equals to work upon the charge. So as we do the cross multiply, so we will get W is equals to VQ, and as you know the power is equals to work upon the time, the rate of the work done. So as we put the value of W here, so we will get VQ upon T, and you know Q upon T is equal to I. So finally we'll get the result, power is equals to VI. Yes, then student, you know very well, if we use any device, any power of the device, so certain time is required to run that device. So to run that device, certain time is required, so that's why the certain amount of heat is produced. So from here, because the heat is producing whenever we use any device for the certain period of the time, so from here we can write heat is equals to power of any device, and time, because time is required to run that device. Yes, so then we can put the value of, or the value of the power, so we can write here VI, and as you know, V from the Ohm's law, we can write V is equals to IR. Yes, so then we will get H is equals to IR into I2, that this is the IT. Yes, then we will multiply this and make it square, so I square H is equals to I square RT. This is the heating Joule's law of heating effect. So from here we can say heat is directly proportional to square of the current, is directly proportional to resistance of the electrical device, and heat is directly proportional to time. As we use any heating device for the longer time, so that there will be more generation of heat. So here student, you can see the practical application of heating effect of electric current. So heating effect of electric current is used in the electric iron, electric toaster, electric oven and electric heater, and many number of the gadget we can see at our home that are dependent on the heating effect of electric current. Yes, here one of the good example of the electric bulb. Yes, so the filament of electric bulb is made up by the tungsten. Yes, why the tungsten used for the formation of the electric bulb? So student, it is used because the melting point of the tungsten filament is around 3380 degrees Celsius. So whenever the electric current pass through this filament, so what you can see in the picture also, so so whenever the electric current pass through the filament, so what will be there, that wire get consume the current and then start to glow. Yes, so this is the phenomena behind the glowing the bulb. Yes, and to maintain the environment, inactive environment in the bulb, so nitrogen and the argon gases and inactive gases is used to for the longer life of the filament. Yes, then student, we will discuss here about the electric fuse. Electric fuse student it is the protecting device of the appliances, gadget as well as the circuit. Yes, so student, from here you can understand what this how this electric fuse protect the circuit and the appliances. So this the electric fuse is the made up by the uh, either the copper, aluminum and the iron wire, and it has the appreciable or appropriate melting point. Yes, and one more thing you need to remember, this electric fuse always connected in a series system. So what is the benefit to maintain connect this electric fuse into the series system? So whenever the high amount of the current pass through into the electric circuit or through the gadget, so same amount of current will pass through this from this electric fuse, and because this electric fuse having the appropriate and enough or some of the time lower the melting point, so what will be there, that wire of the electric fuse get melt down due to the low melting point and save the our gadget. So this is about the electric fuse, very important part for the exam point of view. Then student, here we will discuss about the electric power. So what is the electric power? So electric power is a rate. Yes, it is a rate at which electric energy is consumed. Yes, so whatever device we use, yes, so how much that device using the electric energy, the what is the rate of consuming of electric energy of that device, so that is the electric power. Yes, and what is the formula? So formula for the electric power is P is equals to VI. From here we can make this formula P is equals to I square R. How? So on the place of V we can write IR, so I and I get multiply and will get this result I square R, and from this I square R will get the result, this is V square upon R. Why? Because from the I square we can put this value V square V upon R, and because I here in the square form, so we'll keep here V square upon R square, and 1 R is in the multiple, so it will cut and finally we'll get V square upon R. The SI unit of the electric power is watt, which is denoted by W. Then the definition of the 1 watt. So this is about the device, yes, the device which carry 1 ampere electric current, yes, and operated, when it is operated, when the potential difference is 1 volt, yes. So that in that condition, when the potential difference is 1 volt uh, in the circuit and the 1 ampere current is flowing, so that device will consume 1 watt, yes, 1 watt of the power. Then student will here discuss about the electrical energy. So electrical energy is the kind of work which is done by the electric current, yes. The formula of electrical energy is E is equals to P into T, and the SI unit for the electrical energy is joule. Student, you need to remember about the SI unit, yes. Any energy, if we talk about any energy that contain the same SI unit, that is a joule, that is SI unit of joule, SI unit of energy, and apart from that, work also having the same energy, that is joule. You need to remember this, okay, don't get confused. Then the commercial unit of the power, so that is kilowatt per hour. So if we try to calculate in the joule, yes, so 1 kilowatt means 1000 watt, and hours means 3600 second. As we multiply them, so we'll get this result, yes. And in the scientific value, if I will write, so 1 2 3 4 5 6, so 10 to power 6, and 3.6 into 10 to power 6 joule is equal to 1 kilowatt hour. So student, this is all about the chapter number 12, electricity, and this is the last video of the chapter number 12. For this chapter, some of the handy tips I want to give you. You need to remember all the formula to solve the numerical of this chapter, yes. Thank you.